Hello again. Last lecture we introduced a notion called a covert channel. If you remember, we had the Bell and LaPadula rules in place, and we were able to write a program that allowed information to flow despite the rules from high to low. And that's a bad thing, because that's what the rules were designed to prevent. So let's talk a little bit today about the covert channels. All right, so what is a covert channel? Well, here's a definition. A covert channel is a path for the illegal flow of information between subjects within a system, utilizing system resources that were not designed to be used for inter-subject communication. Kind of a long definition, but let's pick it apart. So, first of all, information flows within the system in violation of the meta-policy, though not necessarily in violation of the policy. We argued last time that we could have a system which satisfied Bell and LaPadula, which was the policy, and yet there were flows which were in violation of the meta-policy. There was a flow of one bit of information from high to low, and that was the problem. The second thing to note about this definition is that the flow is between subjects within the system. That is, we care about using the mechanisms of the system to implement the flow. If you have two guys talking in the hall and one of them gives away some secret information, that's not a covert channel. That's just stupidity, I guess. And then the third thing is, how does the flow occur? Well, it occurs by the high-level subject manipulating some attribute of the system that a lower-level subject can see. That attribute will not be the contents of the file. If you could modify the contents of a file and then have the lower-level user see that, well, that would just be in violation of either simple security or the star property, and that would be in violation of the policy. We're talking about something a little more subtle here. Okay, so let's look at a few covert channels in realistic systems. In this first channel, suppose that you have a high-level subject and a low-level subject, and of course information is not supposed to flow from high to low. And yet, the low-level subject can attempt to access a high-level resource and gets back an error message, actually gets back one of two error messages. If it's possible that the high-level subject can manipulate the status of the resource in such a way that he controls the error message that the lower-level subject sees, he either gets back resource not found or access denied, say, then by doing that, he can send a bit of information through this channel to the low-level subject. And that's a classic storage covert channel. Why do we call it storage? Well, because the high-level subject is essentially storing something into the state of the system. In this case, the status of that resource, which is used as the vehicle for sending that bit of information. Okay, covert channel number 2. Imagine you have two processes, P and Q, and they're not supposed to communicate with one another, but they're on a round-robin scheduling scenario. What that means is that P runs, Q runs, P runs, Q runs, and so on. Okay? Now imagine that they're allocated a particular quantum of time to run in each case, say T units, but it's possible that a process can give up the processor early. So maybe P runs for T units, and then Q runs for T units, and then P gives up the processor early the next time, so he only runs for 1 unit, and so on. Well, how can you use that for a covert channel? Well, Q can observe how long it's been since he was last scheduled. Is it T units or is it 1 unit? How does he do that? Well, he just looks at the clock on the wall and notes when he relinquishes the processor and when he gains it again. And if that interim varies, then P can use that to send information to Q. Excuse me. All right. So this is called a covert timing channel, because actually there's not information stored in the system in any way, but what's happening is that Q is noticing something about either the timing or the sequencing of events on the system. That's what makes it a timing channel. Okay. So how about covert channel number 3? Well, in this case, once again, processes P and Q are not allowed to communicate, but they share a disk drive. And the way the disk drive works is, if I request that the drive return to me the values of, say, sectors A and B, then it will return me sectors A and B, but it may return them in the other order. And the order depends upon where the read head was left. Is it closer to A or is it closer to B? And it goes to the closest one first. Well, you see how this works probably. What P does is leaves the read head closer to A or closer to B, and then Q attempts to read those two sectors, and he'll either get the results back as AB or as BA. And then he writes down either a 0 or 1 depending on what result he got. And thereby P has sent a 1 bit of information to Q. In this case, you might ask whether this is a timing channel or a storage channel. It's not entirely clear because there are sort of aspects of both there. And you might think about that question. As a final covert channel, we're going to look at what's called an implicit channel. What an implicit channel is, it's running a program and using the control flow through the program to send a bit of information. So imagine you have a program in which you have some high-level variable, H, and a low-level variable, L, and it would obviously be bad to just take the value of H and write it into L. But that's not what happens in this program fragment. What happens is, depending upon whether H has a value which is even or odd, the value of L is set, according to the program logic, to be either 0 or 1. And so what's happened is the value of L has been influenced by the value of H. Now, people have worked a lot on these kind of problems and built what are called language-based information flow tools, which analyze a program and can find the sort of information flow from one set of variables to another. And if so, you can rewrite your program. Okay, so we've looked at 4 different examples of covert channels, and they're all quite different. As you might guess, any way in which H can modify some system attribute that L can sense is a way in which information can flow. And so people have looked at this problem and given kind of a taxonomy of different ways that might happen. For example, you might have a timing channel which looks at how much time a particular computation takes, or an implicit channel which looks at the flow of information through the control flow of a program. A termination channel, does a particular computation terminate or not? A probability, this is a little bit odd, but suppose that a low-level process is accessing a random number and he always gets evens or always gets odds or something like that. Then it may be that the high-level process is somehow manipulating the probability distribution of what he's seeing and can thereby send information. A resource exhaustion channel is one where a resource is either exhausted or it's not. So you run out of disk space or something like that. And then a power channel is how much energy is consumed by a particular computation. And if the low-level process can sense that and the high-level process can modulate that, that is a vehicle by which information can flow. In practice, a lot of times researchers really only distinguish between storage and timing channels because that seems to be the big distinction that people make. Okay, so what have we learned? Well, we've given a definition of a covert channel. Remember what that is: any path for information between subjects utilizing system resources that were not designed for that purpose. And then a useful distinction is often made between storage and timing channels, though in practice we've seen at least one channel in which it was difficult to determine which it was, a storage or a timing channel, because it actually had aspects of both. Thank you.